So model-based inquiry, MBI, is a curricular framework that is designed around the tenets of the framework for K-12 education as well as the next generation science standards. So it's an NGSS-based curriculum framework. But what makes it different than other things that are out there is that it is one phenomenon based. And so what we've learned from those who study learning in classrooms is that having something real that we're trying to figure out really helps students make sense of the science as they're learning it. So in traditional classrooms, what we would often do before is we would say, we're going to teach you these really abstract concepts, and then at the end ask you to apply it. Well, phenomenon-based instruction flips that on its head and says, here's the thing we're applying it to. Let's learn the science ideas that are relevant along with each other as we figure it out. So that's one piece. Another piece of it is that we are focused on practices. And so we are highlighting the practice of modeling, because what modeling gives us is a way for groups of people to make sense of and figure out how to apply new science ideas to this phenomenon. So we use that as a way, as a tool to go all the way across an entire unit for students to help make sense of the science. And then finally, we integrate this idea of explanation. And so the summative assessment of an MBI unit is not a test, it's not multiple choice, it is written, and it is a written scientific explanation that says, here's the phenomenon at hand, and step by step, here's how we use the ideas of science and the evidence we've gained during this unit to explain this phenomenon. So an MBI unit has pulled, what we've done for the framework, I should say, is to pull together the different pieces that we have learned through research in classrooms, whether about how students learn or about how curriculum can be developed, and pulled them together into one place.
My name is Jennifer Askew, and I have been teaching chemistry for 16 years now. So I feel like with the MBI units that I implement in my classroom, that there is a little bit more buy-in from the students. They understand what the expectations are with the MBI units, where they know what the end goal is. With like a traditional unit, they don't necessarily know that the end goal would be that they're able to look at the periodic table and understand all its mysterious trends. But through an MBI unit, they know that at the end, I'm gonna be able to answer this question, but I'm gonna be able to answer this question with the chemistry content that I learned in the classroom. So the Hindenburg unit is maybe not the most exciting story, but the Hindenburg unit is a story that I would say 80 to 90% of my kids have heard of the Hindenburg. They knew it was an airship and they knew it exploded. And so they have enough background knowledge in that ship exploding that they do then, once the driving question is presented to them, which is pretty simple, just how and why did the Hindenburg burn so quickly? They do kind of ask themselves like, what? Yeah, why? With the Hindenburg unit, it's basically just an explosion, and in chemistry, that's what students always want to see, is an explosion. And so just getting into chemical reactions, and any type of chemical reaction, but having it framed in the framework of the Hindenburg chemical reaction and having them trying to figure out what's going on and where energy can come from, and how you can end up getting extra energy out of a chemical reaction. But then also, behind the scenes, they're learning how some chemical reactions absorb energy, and then them being able to look at the example of what they think's happening is not always the case. Like, for instance, not giving anything away here, but during the Hindenburg reaction, the product's water. And the idea that water is what is formed in this huge explosion, blows their mind.
My name is Audrey Baird Wolf, and I teach biology. I used to teach chemistry. I also teach AP Environmental Science and AP Physics. I feel like NBI is how we tell a story, and it's how we tell the story of science, basically. And where the traditional unit kind of puts random content in front of students that is based on chapters, this style of teaching incorporates real, actual things that students have either wondered about or are going to wonder about because we're going to bring it up to them. So based on real phenomena, real people, real scenarios, where uncovering the information helps us understand what is it or what happened or what caused something, rather than here's some random material that you're supposed to learn because we're supposed to learn it. So it puts everything in context. Aside from engagement, I think it has significantly altered the way that students see science, where they might not have related to it before, because maybe they have only been experiencing like, here's a lecture and you're supposed to know this because I say so. The level of like curiosity and ownership of learning has changed, the way that I will implement a unit, even if it is, a unit that I've done many, many times. It's really neat to see when students like want to look at something different. So when we're coming up with like, what do we need to know in order to figure out the answer to this driving question, that different things come up every single year. And so it, for me, doesn't feel like it ever gets like stale or old, because there's always different stuff that students want to know more about. And so there's always an opportunity to like throw in some cool new things that I didn't even think about before. So I think it's kind of lended itself to more flexibility, even though it might be a similar, if not exactly the same phenomena for multiple years.
I just wanted to share some of the resources that teachers can expect to see if they reach out to our website. So on our website, we have some example units to get a sense of what MBI can look like and some resources you could pick up and use right away in your classrooms. There's also a design template, so you can go there and construct your own unit based on with the template that we have there. This way you could localize your model-based inquiry instruction for your students in your local community, region. We also have ideas on there for phenomena that you might pick up and design a unit around. And then we have also created some resources for like how to facilitate a discussion, how to ensure you get students' ideas on the table to work with and on. We also, the final thing I'll mention is we have some NSTA books, MBI biology book for high school biology, and then we have a chemistry book. Each have 4 units. You can use them in your classroom across the academic year. And we have a link for how to get those books at our website.